It's another exciting day here in Algebra 2 land. Today we are looking at operation and compositions with functions. So we can take two functions, and any normal operations that you could do with a set of numbers, you can also do with two functions. I can sum them, which means I just take my two functions and I add them. I do any simplifying I can with like terms. I can subtract them, and then same story with combining like terms. I can multiply them, and I can divide them. So this is the notation that you will see for those four operations. Another thing we can do with these is something called composition, which is where I substitute one function for the variable of another. So we are going to first explore doing each of these operations with these functions. I have f, g, h, and k, and part A wants me to do h plus k of x, which means I'm going to take h of x, which is 2x squared plus 3x minus 1, and I'm going to add k of x, which is 4x minus 5. Now, there's nothing to distribute here, so everything is going to keep the sign that it currently has, and I'm just going to combine any like terms that I possibly can. There's no other squared term. 3x plus 4x gives me 7x, and negative 1 minus 5 is negative 6, so our h plus k of x is equal to 2x squared plus 7x minus 6. The next one wants me to do the product of h and k, so I'm going to take h of x, which is 2x squared plus 3x minus 1, and multiply that by k, which is 4x minus 5. And I'm multiplying a trinomial and a binomial, which means I'm going to be doing multiplication 6 times. So if I do 2x squared times 4x, that gives me 8x cubed. 2x squared times negative 5 is negative 10x squared. 3x times 4x is 12x squared. 3x times negative 5 is negative 15x. Negative 1 times 4x is minus 4x. And negative 1 times negative 5 is positive 5. So to get our h times k of x, I can combine like terms. I don't have anything else with an x cubed. Negative 10x squared plus 12x squared gives me 2x squared. Negative 15x minus 4x is minus 19x. And then I still have that plus 5. H minus k of x tells me to subtract. So I'm going to take h of x again, 2x squared plus 3x minus 1, and I'm going to subtract k of x, which is 4x minus 5. So what this is going to require me to do is distribute that negative before I can combine any like terms, so that becomes minus 4x and plus 5. So our h minus k of x, once I combine everything, will be 2x squared. 3x minus 4x is negative x. Negative 1 plus 5 is positive 4. Okay, another subtraction, but this time with two different ones. And the reason we are stressing this one is because year after year, kids will forget to distribute that negative. So here's my f of x function, and I'm going to subtract g of x. So again, I'm going to distribute that minus sign, and I'm going to get negative x minus 2. So to get f minus g of x, combining like terms, I'll get x squared plus 5x minus x is 4x, and then 6 minus 2 is also 4. On to E, this one is division. I'm going to divide f and g, so that's going to be x squared plus 5x plus 6 divided by g, which is x plus 2. Now, when you are simplifying fractions, remember you are simplifying and canceling out common factors. So if I look at this top, this is not in factored form, but I can put it in factored form if you need your x method to help you get there. 6 and 5, the two numbers that multiply to 6 and add to 5 are 2 and 3. So this factors to x plus 3 times x plus 2. I do now have a common factor with my denominator that I can divide out. So f over g, or f divided by g of x, will leave me with just x plus 3. Okay, now the very last one, the one that looks brand new, g of f of x. So what this means is I'm going to take my f function, which is this entire thing, and I'm going to substitute it into x into my other function, which in this case is g. And the way I know to do it in that order is because f is on the inside, which tells me f is what's being plugged into g. So what that will look like is x squared plus 5x plus 6. That is where x goes, 2. So here the only thing I'm going to be able to combine are my constants. So here g of f of x will be x squared plus 5x plus 8. So we're going to do a little more work with that new stuff. Here on example 2, I have 2 new functions, and I want to find g of f. So that open circle is another way to represent composition, g of f. So this is again telling me I'm taking f and I'm substituting it in place of x in my other function. And here that is happening in 2 places. So what that will look like is x plus 3 squared minus 2 times x plus 3 minus 15. Now, keeping in mind when you square a binomial, you do not distribute. This is saying x plus 3 times x plus 3, so really you are FOILing. And so what that will give you is x squared plus 6x plus 9. Then here I need to distribute the negative 2. And then that minus 15 is still on the outside. So after all is said and done and I'm combined my like terms, g of f of x will be x squared, 6x minus 2x is 4x, and then 9 minus 6 minus 15 is negative 12. Okay, another example with composition, I want to find g of f of 3. Now there's 2 ways I could do this. I could start with the inside and find f of 3, which we know how to do by evaluating functions. This would be 3 times 3 squared minus 2 times 3 minus 3. Well, order of operations, 3 squared is 9. Continuing, that gives me 27 minus 6 minus 3, which is 18. Okay, now that I know f of 3 is 18, this would be equivalent to finding g of 18. Well, I know how to find that as well. G of 18 is negative 18 plus 15, which gives me negative 3. Now that's one way I could do it, but that had me plugging things in twice. So what if instead I first found g of f of x? So what that means is I would take my entire f function and plug it in for x in the other. So that would be negative 3x squared minus 2x minus 3 plus 15. I don't have to FOIL here, but I do need to distribute the negative. So that would give us negative 3x squared plus 2x plus 3, and then I still have that plus 15. So our final function after I combine my like terms would be negative 3x squared plus 2x plus 18. So if this is g of f of x, I could find g of f of 3 by plugging 3 in to my composed function. And I will get the same answer. So if I plug 3 into this one, again, order of operations, 3 squared is 9. Negative 3 times 9 is negative 27, plus 6 plus 18. So negative 27 plus 6 plus 18 is also negative 3. So this way had me evaluating 2 functions 2 separate times. This way allowed me to do it one time in one function. Okay, so that is composition algebraically. We can also do this graphically and from a table. So we are going to look at graphs first. We know how to evaluate points on a graph. And what we're told here is that the solid line is f of x, and my dashed line, which should have continued up here, is g of x. So again, we're working from the inside out here. So on A, the very inside portion says g of 2. Well, to find g of 2, that means on my graph, I'm going to go to where x is 2, and I'm looking at my dashed line, and the y value also happens to be 2. So that means what I'm now evaluating is f of 2. So I'm going to go back to where x is 2, but I'm going to look at my solid line this time, and that y value is 0. So my final output, my final answer is 0. On to the next one, starting with the inside, f of 2. Well, we just learned that that is 0. So now what I want is g of 0. So where x is 0, I'm looking on my dashed line that is down here at -3. F of g of -4, when x is -4, g is down here at -3. So I want f of -3. So if I go to -3 up to my solid line, that is at 2. F of 0, so starting with the inside, I want to find f of 0. So 0, the solid line is at 1, which means now I want to find f of 1. And we're going to kind of eyeball where that is because it's not perfect, and I'm going to call that 1/2. G of -2, so starting with g of -2, down here that is kind of at -2.5. So if I want to find g of -2.5, I would go here, and I'm going to call that pretty close to -2. That one's not perfect. F of -4 is where I'm starting on the next one. -4, my solid line is at 2. So now I want g of 2. So when x is 2, g is 2. Now this one is a 3-part, but I'm just going to work from the inside out, starting with f of 0. F of 0 is 1. So I now need to find f of g of 1. So my new inside here is g of 1. So when x is 1, what is our g? Well, it is here at 0. So now I need to find f of 0, which again is +1. Okay. We can do a similar set of problems from a table. This time, instead of looking at the graph for my outputs, I'm going to use my table. We still start from the inside out. So on A, if I want to find g of 2, I'm going to go to where x is 2, and I'm going to look at the output for g, and that's 5. So now I want to find f of 5. So when x is 5, I'm going to look at the output for f, which is 7. On B, I'm starting with f of 2. So when x is 2, I look at the output for f, which is 1. Now I want to find g of 1. So when x is 1, my output for g is 2. On C, starting with g of -1, when x is -1, my output for g is 2. So now I want f of 2. When x is 2, the output for f is 1. G of f of 4, when x is 4, my f output is 5. So if I want to find g of 5, when x is 5, the output for g is 26. Starting on E, inside g of 1, when x is 1, the output for g is 2, which means I now want to find f of 2. When x is 2, the output for f is 1. F of g of -2, when x is -2, the output for g is 5. So now I want to find f of 5. When x is 5, the output for f is 7. G of f of 3, when x is 3, the output for f is 3. So now I also need to find the output for g when x is 3, and that is 10. And then lastly, g of f of 1, when x is 1, the output for f is -1. So now I want to find g of -1, which is 2. Okay, I'm running out of time on this video, so I will do the next examples in a second part, but this is going to look at where this is also more helpful in a similar real-world context.